Okay, let's dive right into this explainer. Today, we're unpacking a really fascinating paper called The Grammar of the Scientific Method. And I gotta tell you, this one completely flipped the script on a foundational story I thought I knew about the history of human discovery. So, who actually invented the scientific method? Most of us, myself included, assume it was figures like Galileo, Francis Bacon, or Isaac Newton back in the 1600s, right? You picture these guys in their labs suddenly unlocking the ultimate secret to rational thought. But is that actually true? What if they didn't invent the method at all, but just give our tools a massive upgrade? This paper asks a much deeper question about how humanity actually solves problems. Think about it this way. The paper uses this brilliant analogy. Claiming the scientific revolution invented the scientific method is literally like claiming someone invented cooking just because they built a modern kitchen with a stainless steel oven and a digital timer. Like, sure, having a high-tech oven makes cooking easier, way cleaner, and a lot more precise, but come on, people were still combining ingredients, applying heat, and tasting the results thousands of years before modern appliances ever showed up. So, here's the crucial point. If you strip away the modern lab coats, the microscopes, and the peer-reviewed journals, you are left with what the author calls an invariant operational grammar. It's made up of 8 primitive steps: receive, differentiate, compare, evaluate, eliminate, preserve, organize, and iterate. That's the whole shebang. Every single valid scientific investigation relies on these fundamental moves, no matter what area you're in. And this brilliantly illustrates how every major definition of the scientific method, whether it's from a textbook or heavy-hitting philosophers like Karl Popper or Thomas Kuhn, ultimately boils down to this exact same simple repeating pattern of investigation. When you map it out, you realize that no matter how complex the vocabulary gets, the underlying actions of the investigator are always exactly the same. You gather the facts, compare them, throw out what doesn't work, keep what does, and repeat the process. Honestly, just think of these 8 steps as the basic Lego bricks of human reasoning. Whether you're building a medieval castle, a dragon, or a space telescope out of Legos, you're snapping together the exact same bricks, right? Well, in scientific terms, whether you're digging up dinosaur fossils, diagnosing a viral illness, or mapping black holes in deep space, you are snapping together the exact same mental operations. Let's jump into the history here, because this is where it gets really fun. This timeline tests the theory by looking at secret scientists who used this exact same grammar thousands of years before the scientific revolution was even a blip on the radar. The paper looks across radically different eras to see if these basic operations hold up. And spoiler alert, they totally do. The subject matter changes, obviously, but that underlying structure of investigation, it persists across millennia. For example, take a look at ancient diagnosticians. The text points out that ancient Levitical priests didn't just arbitrarily guess about skin diseases. They actually acted a lot like early medical detectives. They systematically isolated patients, observed how the symptoms progressed over a set amount of time, compared those results with past observations, and then eliminated false diagnoses. That is, receiving, differentiating, comparing, evaluating, and eliminating. It's the exact same grammar at work in antiquity. The paper even examines public inquiry in historical religious texts. It notes how Jesus of Nazareth used evidential reasoning when he was questioned about taxes. Before making a judgment, he asked to publicly examine the tax coin. He was differentiating the physical image of Caesar from divine authority and comparing those competing claims. Rather than just falling for a false dilemma, he evaluated the evidence right there in front of his audience to form a reasoned conclusion. It's a structured sequence of thought. And this historical continuity lines up perfectly with what much later philosophers formalized. Fast forward to 1843, and you have John Stuart Mill talking about observing uniform sequences in nature. He argues that we have to resolve the complex uniformity of the universe into simpler uniformities. Basically, he's talking about taking the massive, overwhelming chaos of nature and systematically breaking it down. This directly reflects that timeless grammar of investigation we've been talking about, just articulated with some serious philosophical rigor. Now, what really stands out in Mill's work is his point that the very first step of inductive inquiry is a mental analysis of complex phenomena into their elements. That maps perfectly onto our differentiate Lego brick. Think about it. You literally can't begin to compare or evaluate a problem until you first separate the relevant features from the totally irrelevant ones. You gotta break the castle down into individual bricks before you can understand how it was built. So that begs the question, if the scientific method didn't fundamentally change, what actually did? Why does modern science look so incredibly different today? While the author argues we have to make a hard distinction between primitive mental operations, which humans have always used, and derived products. Derived products are things like microscopes, formal experiments, and calculus. Modern science simply perfected these derived products, which gave us unprecedented ways to execute those underlying primitive operations. It's exactly like basketball shoes. Inventing fancy high-tech sneakers didn't invent the game of basketball, right? The objective, the rules, the physical mechanics of the game, all of that stayed exactly the same. The new shoes just let the athletes play the game with far greater precision, speed, and grip. Telescopes, supercomputers, statistical models, these are basically just the high-tech sneakers of human enquiry. When you synthesize Mill's detailed definitions with that 8-step grammar, it becomes crystal clear. The scientific revolution did not invent how humans think. It simply gave humanity much better tools, better mathematical languages, and better institutions to execute this timeless grammar of inquiry more powerfully than we ever could before. Now I know exactly what you might be thinking right about now. But wait, what about controlled experiments? Didn't they change absolutely everything about how we discover truth? Surely setting up a sterile lab with control groups and placebos is a completely brand new way of thinking, right? How on earth does that fit into a grammar that supposedly existed thousands of years ago? Well, let's break it down. An experiment is not some magical new step in human logic. As the paper points out, it is simply a highly organized sandwich made out of those exact same 8 primitive Lego bricks. When you run an experiment, all you're doing is structuring how you receive data, compare conditions, evaluate results, and eliminate failed hypotheses. The exact same thing goes for mathematics and measurement. They are complex combinations of the basic 8 steps, not replacements for them. And what about human creativity? Even things like a sudden burst of imagination, a strong gut intuition, or testimony from an authority figure, they just give us the raw ingredients. Sure, an intuition might kickstart an investigation, but for it to become justified, reliable knowledge, it still has to pass through that 8-step grammar. You still have to compare your brilliant creative idea against hard evidence and evaluate it. No shortcuts. So the grand takeaway here is what the author calls the invariance theorem. This theorem concludes that the scientific method is actually an invariant grammar of disciplined inquiry, meaning it is a universal, timeless rulebook for rational thought, absolutely not just a modern European invention from the 1600s. As long as humans have been carefully seeking truth and solving complex problems, they have been relying on this exact framework. And because it's so universal, this explainer highlights that we are all actually playing the exact same game. Whether you're a lawyer cross-examining a witness, a doctor diagnosing a patient, a historian comparing ancient texts, an engineer designing a bridge, or even an AI training on a massive dataset, you are running these exact same operations. The subjects differ, the tools differ, but the underlying thinking muscles, they are completely identical. Which brings us to our final thought. If the scientific method isn't just some exclusive club for scientists and lab coats, but is actually the native, hardwired grammar of human thinking, what will you build with it today? You already have the tools. You have the fundamental Lego bricks of reasoning. It's totally up to you to start snapping them together to solve the problems right in front of you. Thanks so much for joining me on this explainer, and keep questioning everything.